So yesterday we started talking about Jody and Riley. Today we're going to continue. Yesterday we filled this all in, right? Today we're going to continue talking about the two of them. Okay? Although more people would buy snow cones at cheaper prices, Jody and Riley also want to maximize the revenue they would generate. So what's our goal for today? What's our goal for today? So to apply our knowledge of characteristics of functions of a real-world problem. Now, some people are like, this is not even close to a real-world problem, right? No one you have ever met owns a snow cone stand. Yeah, those are funny faces that you're giving me because you're like, yes, we do. Oh, so wait, this is a real-world problem? Oh, my goodness. Extend the data table to calculate the revenue they would generate according to the data collected for each price and the number of people that would purchase at that price. Okay? So, if we have 25 cents for a snow cone and the number of people that would buy the snow cones at that price is 75, we have 0.25, so 25 cents times 75 people would give us how much revenue? $18.75. And how did you figure that out? Put it in your calculator, didn't you? Which you all picked as you came into the room, right? You all picked up your calculator as you came into the room. Huh? 50 cents. 70 people. So we're going to say 50 cents times 70 people equals what? Please don't put this one in your calculator. Can't you do this one by yourself? In your own head? What's 7 times 5? 35, right? 70 times 5 would be 350, but I'm not multiplying it by 5, I'm multiplying it by 0.5, so it's going to just be 35. So then I have 0.75 times 65. 0.75 times 65? Anybody got that in their head? I don't, for the record. 48.75. So continue on your table. Check up to mine every so often to make sure you're doing yours correctly. $1 times 60 is going to be $60. $1.25 times 55 people. It's going to be $68.75. $1.50 times 50 people. It's going to be $75. $1.75 times 45 people. It's going to be $78.75. $2 times 40 people is going to be $80. I'm going to go ahead and fill these in. $2.25, $2.50, $2.75, $3, $3.25, $3.50, $3.75, and $4. I'm also going to fill in the number of people, because I know it's decreasing by 5. So 35, 30, 25, 20, 15, 10, 5, and 0. So here I have 225 times 35. 225 times 35 is going to be 78.75. 250 times 30 is going to be $75. 275 times 25 is going to be $68.75. $3 times 20, that's going to be 60. 325 times 15 can be $48.75. 350 times 10, well, that's 35. Hopefully we see that. 375 times 5 is going to be $18.75. And $4 times 0 is $0. Any questions on completing the table? So the cost of the snow cone is X dollars, correct? What did we figure out yesterday that the number of people that would purchase at that price would be? What's this? You remember? Which one was it? 80 minus 20x, right? How could you know that if you didn't remember it? Look back, right? Look back at yesterday's table. Okay? What's the process to compute the revenue? What did we do every time? Multiplied what? The cost times the people, right? So if I multiply the cost times the people, doesn't it look like that? So then what is x times 80 minus 20x? $80x minus 20x squared. Okay? So let's make a scatter plot of this data. What goes where? It tells you, right? The revenue generated versus the price. Y versus X. Revenue here and price of the snow cone. Now, I purposely didn't put price as money, right? Why? Do you know? What's revenue? Money, right? So I didn't just put dollars or cost and cost. We have to be very specific what we're talking about here because of the fact that these are in the same kind of units. Okay, so be careful about that. How are we going to scale our price axis, our x-axis? That's here, right? Cost of the snow cone. 0.5. Why would I do 0.5 instead of 0.25? Yeah, there won't be enough room, will there? Okay, so 0.5. So this is a 1, a 2, a 3, a 4, and a 5. Do I have to put the ones in the middle? Like 0.5, do I have to put that? Can I if I want to? Okay. How am I going to scale my revenue axis? Where does it have to be able to go? To 80? So how did you say you wanted to scale it? Tens? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now we just need to plot our information. Okay? 0.25 goes to 18.75. 0.25, 18.75. Is that close? Okay. 0.5 is 35. 0.75 is 48, so almost 50. 1 is 60. That's easy to find. 1.25 is 68.75, so 1.25 is almost 70. 1.5 is 75. 1.75 is almost 80. And then 2 is 80. And then 2.25 is almost 80. 2.5 is 75. 2.75 is almost 70. 3 is 60. 3.25 is 48.75. 3.5 is 35. 3.75 is 18, almost 20 basically. And 4 is 0. Is yours as beautiful as mine? Of course it is. Any questions about this? You know what this crazy kid said to me last period when I said, is there any questions about this? They were like, should we connect them? What did I say? I said, good question. Should we connect them? Right? It's either yes or no. That makes it easy, right? Okay. What do we think about if we're trying to decide if we should connect them? Okay. Can we have partial money? Can we have partial money? Yes, we can, right? In this situation, can we have parts of money? No. Do we connect them? No. Okay. Oh my gosh, but look what that helps us answer. Look at 15. Doesn't that help us answer 15? What's the answer to 15 then? Discrete. Good. Okay. And this crazy kid was like, but Miss Kingston, we can have partial money. What did I say? Yes, you can, right? But not in this situation. Because we want to only count by quarters. Why would Jody and Riley only want to count by quarters? Have you ever helped run a concession stand? Have you ever helped run a business? You really want to keep pennies, nickels, and dimes on hand? No way, right? So they're probably, well, we'll get to that just in a second. I don't want to ruin the surprise. What are the independent and dependent variables in this situation? Where could I look if I didn't know? Back at the table or the graph, right? Or the words. Our independent value. Oops, I have to write this way, sorry. Is the cost of the snow cone. Another place that we don't want to just write money, right? Or dollars. Okay? What is the dependent value? Revenue. What is an appropriate domain and range for the problem situation? Well, I've already decided it's discrete, so that helps me a little bit, doesn't it? What's an appropriate domain? Okay, so that's what she said, right? 0 is less than x is less than 4. How do you feel about that? We talked about this already yesterday, right? Okay, and what I need you to understand is from class to class, depending on their reasoning, depending on their justification of their choices, I wrote that a little different. Okay, what did we write as our domain yesterday? Look back if you need to. What did we write as our domain yesterday? Are these just less than? Okay. In some of my other classes, they wanted the or equal to. Why did they want the or equal to? Because if you look at the data that we collected, aren't all those values on the list? Yes. Now, 0's not, but couldn't we easily find it? 80, right? And so there were some classes yesterday that wanted the or equal to, and that was their justification. It's on the list. We want it as part of our domain. And I said, okay. because they justified their reasons, right? So on a test situation, I don't know, maybe tomorrow, if you don't know which one to put, justify why you put which one you put. If you can justify it and it's correct, I'm going to give you credit for it, even if it's not what I have on my answer key. Okay? This is not one of those things that it's hard and fast. We do it this way every single time. And you know how I feel about that anyways, right? If we can do it your way and your way works every time, we're doing it your way. Okay? So is this how you want it? Is this how as a class you guys want it? Okay? So that's wrong. Oh, okay. So you want me to write counting by 0.25. Oh, that's right. That's good. Remember, it's a discrete situation, so we can't just have this. We have to have a reason. We have to have a condition. Fair enough? Okay. What's the range? So what I heard was 0 is less than y is less than 80, counting by 5s. Excuse me? Okay. Does this go from 0 to 80, counting by 75s? Because the next one here then should be 19.5, right? Ooh. So we can't do it that way, can we? Not this time. So what do we have to do this time? We have to list them all. How many of them are there that we have to list? Oh, there's some twice. Do we have to list them if they're there twice? No. 0. 18.75. 35. What's next? Help me out. 48.75. What's next? I'm sorry? 60. 68.75. Can I put ... I mean, we did that a couple times ago, right? Does it keep going? First of all, is there a constant change in here to begin with? No, so I can't put ... because I don't even know what's happening next. But aren't these the only range values we have? Done. Number 14, is the relation increasing or decreasing? Yes. Wait, where is it increasing?